Hello, everyone. Those are bright lights. Thanks, everyone, for coming today. So welcome. I know this reInvent is pretty awesome. Having this my fourth or the last. I've been to every one, and it's just awesome to see how much it's grown. So my name is Aaron Newman. I'm the CEO of a company called CloudChecker that gives you visibility and control of what you have running in AWS. And what I'm here today to talk about, though, is security in the cloud. What's changed? How do we rethink security in the cloud? How do we need to do things different than we used to do on-prem? When we had our data centers, there was a way to do security. As we're moving to the cloud, there's a lot of rethinking of that. You have to rethink how you're going to do that so that you do stay secure. I mean, one of the great parts that I'm actually starting to see is that people are starting to get security in the cloud. It used to be, the conversation used to be, is the cloud secure enough? We have actually finally moved away from that question, and now I'm starting to hear people talk about, well, the cloud is more secure. And it really is. I mean, and there's a couple things. That's not necessarily doing a lift and shift. You can't say whether it's more secure or not. It's probably the same. But as you rethink your things and redeploy things in a more cloud-centric way, you really get a lot of advantages, and the cloud actually becomes much more secure than our on-prem data. So today we're going to talk about, what to expect. So we're going to talk about this perspective as you move to the cloud. How am I going to rethink things? How am I going to approach security? How am I going to change things like intrusion detection, activity monitoring, vulnerability assessment? How do I do these things in the cloud? Very different. And then gain a better understanding. What are the tools that that AWS provides me to help me do this? So they give you a lot of tools. And the question is, what tools are you going to use? How are you going to use them? And that's really the shared security model we're going to talk about as well. So we need to rethink it. You know, things like, what's my perimeter, right? It used to be in the old data center, I'd have a perimeter, and I could scan it, I could verify that it was locked down. What is my perimeter in the cloud? You now have workloads that are running in this shared infrastructure. Your perimeter fundamentally changes. Doesn't mean you don't care about your perimeter. It just means how you're going to define it, how you're going to understand it, how you're going to monitor it is very different. You're going to have to rethink these standard tools like vulnerability assessment, penetration tests, network scanning. How do I do those differently? You know, and then focus not necessarily on just locking down your resources. I mean, it used to be you thought about this. You know, your perimeter was where you secured everything. Once somebody got inside there, then it was often referred to as a hard, crunchy outside and the soft, gooey inside. Once an attacker got inside, it became really, the security was very low. So we want to rethink how we're doing that because we don't have this perimeter the same. We want to think about how am I going to secure assets, where they sit, how am I going to secure workloads, not necessarily how am I going to secure my entire infrastructure. So we really need to think about these things. I mean, in the data center, it was all about you'd set up infrastructure, physical infrastructure, you'd hire guards or you'd co-locate something, you'd have locks, physical locks, all of that. You know, when you wanted to audit your security, you'd go buy a tool and do, for instance, port scans, network scans. All of this has changed. You do a lot of things like sniffing packets. You'd be sitting there in the network because you own the network. You could see what's going across it. These are all the things we do in the data center. They don't work today, right? You can't sniff packets. It's very tricky to sniff packets in the network. You don't have a port. You don't have a span port you could just stick a device into and listen for attacks anymore. You now have to think about how am I going to do this a little differently. So what's different? This idea of physical security. Physical security is really morphed, and now you have this virtualized AWS. You know, the AWS API is really the same as physical security. In the old world, you'd buy a hard drive, it gets shipped to you, you'd install it somewhere. Today, the same thing is just calling an Amazon API that creates an EBS volume. Right? So that means we still have to lock that down. We have to figure out how we're going to secure it. But these concepts are important. Things are ephemeral in the cloud. They're auto-scaling. And how am I going to manage that differently than in the old world? In the old world, the security guy would say, give me a list of your servers, and I'll go check the security of those, right? If you have ephemeral workloads that are getting spun up and down, how does that change? How are you going to give a list to your auditor your security auditor to go check it out? So, you know, we're going to see this slide all over the place. The shared security model. where you're getting a lot of the security responsibility taken away from you. You don't have to worry about, disposing of hard drives. You don't have to worry about putting a guard with and monitoring systems and all that in place. AWS takes a lot of that responsibility off you. They have the availability zones, they have the physical security, but you still have a lot of how are you going to control access. There's no questions. AWS gives you every possible security configuration or setting you could want. You look at S3 and there's 80 different ways to, and 80 is exaggeration, but there's every different way to encrypt, every different way to audit, every different way to provide access controls to it. But the question is, are you doing it right? It's just time and time again, I go to customers and I see somebody putting a network, what's a network share, an S3 bucket. That's the equivalent today, and just leaving it wide open to the button, to the world. That's the part that's our responsibility. That's the part that we have to worry about, is not doing dumb things like that. I always say, so what's the biggest security hole in the world? It's humans, right? Humans are the ones that cause the security problems. They're the ones that misconfigure things. They're the ones that are vulnerable to social attacks. They're the ones that click on the phishing emails, things like that. So one of the best ways to lock down and to really make your security better in the AWS environment is really to take away as much of the management control as the management console as you can. Right? If people are going in there and setting security settings within the console, they're usually doing it wrong. Right? Really, one of the key tenets that makes the cloud so much more secure than the data center is this idea of security automation. Automation fixes so much. The idea that you can repeatably deploy micro-segmented networks that are properly locked down, if you can automate that, that raises the bar of security so much higher. In the old world, the problem was you had humans going around and configuring a Cisco router here and configuring a firewall there and going and setting permissions in a file share, something like that. So we want to eliminate the humans out of the problems, and the key to that is security automation. So in a perfect world, everything you deploy in your environment should be all automated. And the security guy's task then becomes just reviewing that automation to make sure that you're architecting it the right way. And once you have that done, then you can automate this and do it repeatably and not worry about the human, where if a human does something 20 times, one of those 20 times he's going to do it wrong. So you want to eliminate humans out of the equation, and that's totally what security automation is about. What's interesting as well is, as I go around and talk with a lot of security people and DevOps and all these different teams, the one thing I've learned is that security people are really struggling with this new cloud world. If you go to the RSA show and you talk to them about security for the cloud, it's still mostly private cloud for them. That's what they think security in the cloud is private cloud. Security automation, right? Security guys don't do a lot of automation. They're not automation guys. You know who really get security these days? DevOps. The DevOps teams really get security. They do a great job of security because it's in your second nature as a DevOps person to do this security automation. The idea of making things repeatable, making things much more secure that way. So what we're seeing is the security people are really struggling with, how do I bring this expertise? How do I understand, how am I going to manage an AWS environment? Whereas the DevOps, a lot of the responsibility is starting to fall onto the DevOps teams to secure this stuff properly. So in the cloud, so all the principles of security don't change, right? There's just principles like you want to reduce your surface area, reduce the attack surface area. That doesn't change. Just defense in depth, that doesn't change. None of these kind of, the application level attacks, those things don't change. So you have to do those the same. So you still have to worry about somebody doing a cross-site scripting attack on your website, or you have to worry about SQL injection. You still have to patch things, and so you don't want to just forget about patching and saying it's in the cloud, I don't need to patch it. You want to make sure you're patching still. We're going to go into a whole new set of challenges as well around how do I patch things. And again, just a little teaser, patching is so much easier in the cloud if you're doing things the cloud way. Right? If you're lifting and shifting, patching isn't going to be that much easier. But if you're doing things in this idea of reprovisioning workloads, applying patches becomes so much easier. So we'll get into that, but you still have to worry about these things. The things that are somewhat different is, again, you have these ephemeral assets, right, that are gone. You have something that's running and then gone today, or gone tomorrow. So what's one of the big challenges in security today? If you read about the target attacks or any of the significant attacks that happen, they're often what they call APTs, Advanced Persistent Threats. And what that means is somebody got a toehold onto one system in a network. And then they had that for weeks, if not months, and then they eventually leveraged that to get a toehold into a second system. And then they leveraged that to get into a third system. And they eventually ended up getting to something that was sensitive. So, most attacks are not just simply, hey, I'm going to throw one packet at something and get your most valuable data, your credit card information, whatever it is, personal PII. It's usually done through these advanced persistent threats where somebody gets into a network, they're sitting there for months. In targets, they were there for months and months and months. And so you had plenty of chance to be able to go find that and eliminate it, eliminate that threat. So now how is that different in the cloud? I mean, so for instance, if I have a workload that's auto-scaling and ephemeral, if somebody does get a toehold into that, it's often gone, in a couple hours, right? So it actually makes it much harder for an attacker to get a foothold, to get an advanced persistent APT and be effective and stay there for a long time. So that idea of auto-scaling is actually, it makes it much harder for an attacker. I mean, the other thing is the attacker in that APT, right? The first thing he's going to do is once he has a foothold, he's going to start trying to map out your network. I mean, and he's going to try to figure out, once he maps it, then he knows he can come up with a plan for his next level attack. So now, again, in a world where everything's changing, the idea of mapping it becomes that much harder. So again, these things are going to make, in a cloud environment, an attacker's life that much more difficult. The other thing is, again, network sniffing. You don't have that ability. So much of our security knowledge, our security infrastructure today that we use is all about how do I sniff packets, and then how do I do everything from behavior analysis to threat detection on it. You don't have the ability to just hook something into the network and listen for it again. So, and we're going to talk about VPC flow logs, which is a nice feature that comes for free or not for free, but comes out of AWS that will give you the ability to see who's connecting, but it still doesn't give you that deep packet content inspection. So we're doing things a lot different in the cloud. I mean, so the answer today really is a lot more of agent-based security. So the focus has changed from the idea of, I put network devices on there, and network devices would protect entire subnets or entire networks. That's become very hard to do because the idea is, if I'm going to try to take a workload and put a device in front of it, it becomes a bottleneck for that device. There's just all kinds of challenges. So the idea of putting inline devices that protect my workloads is much less feasible. So what we're seeing is really a focus much more on agents, people putting agents on boxes and that becoming your protection, protecting it right at the source. That has good and bad, right? I mean, some of the challenges is how do I get an agent installed on 10,000 of my workers across my entire infrastructure? If you have 10,000 instances, that's very difficult to do. Whereas in the old world, if you could put 5 devices that sniffed all the traffic at egress and ingress points, it's much simpler to do. But even the idea of putting things on the agents on the endpoints becomes challenging too, because again, so we always have to be thinking about what's going to happen in the next 5 years. What's going to happen next? Think about what again is a big hot topic, serverless architectures, right? Serverless infrastructure. Well, serverless infrastructure means we can't put an agent on it, right? So we have to start thinking again, as much as we're just barely able to keep up with how do I rethink security in the cloud today, we have to start reinventing it again for tomorrow too. Because once serverless architecture becomes standard, now what do? I can't put an agent on there. As Dockers and containers become more mainstream, the idea of putting an agent on some Docker container that's going to be spun up for 2 minutes and then spun back down doesn't make as much sense, right? I mean, the agent is really designed and the intention is to be there for something it's expecting to be there for days, weeks, whatever. So we really have to keep thinking proactively about this idea of agent security is where we are today. That's the best way to do it in the cloud, but it's not going to be the long-term strategy. So perimeter, your perimeter in the cloud. What was your perimeter? It used to be, again, the old world where you had a data center, you'd have firewalls on the external side, you'd have IPS and IDS devices. To map out the perimeter, you'd use tools like Nmap, and you'd do port scans and ping sweeps, all of that. Right? So you can't do that in the AWS infrastructure for multiple reasons. I don't think even trying to do some of the ICMP stuff, the tricks that they use to map networks, probably doesn't even work based on how the protocol works within AWS. But I mean, the key is really it's against the terms of service, right? You just can't go out there start flooding the network with packets meant to do discovery because it's not your resources. These are not your assets. You're sharing them with other people. So you have to rethink, well, how am I going to do this, right? So the new concept is, the idea is the whole world is now software-defined networking, or the AWS environment is software-defined networking. Infrastructure is code. What does this mean? This means that rather than physical devices that are routing my stuff, it's configuration options. It's those things that define what packets are allowed through, where devices sit, where resources are. So actually, software-defined networks make discoverability and mapping your network significantly more reliable, right? So that's a huge, huge advantage. I mean, the biggest problem with the old world, or one of the problems of the old world, was sometimes your mapping was highly inaccurate because some devices had, if something had a blocked port, you might not even discover it even though it was there. So it was highly unreliable how you would do these network maps. In the cloud, in the AWS environment, you have a very, very discrete list, and you can know exactly what resources are on this subnet. You can know exactly what packets are allowed through, in and out. It's highly defined, so it makes it very reliable to get a map. Now the challenge is there's so many options, configuration, resources, that it's not as simple as just making one or two API calls. It's really, how do I tie all these API calls together to create a complete map of everything that's in my environment. And you can see, you want to do a network map. I mean, and a network map is the most important thing, because if you don't know where your resources are, you can't secure them. So first thing a security person needs to do is define, what does my network look like? Let me pull up a map and use that to then make sure that I've locked down all my resources properly. So, you have things like security groups, you have routing tables, you have network access control lists, you have VPCs and subnets, you have, things that sit outside of the VPCs, S3 buckets, what permissions are on them, IAM policies. All these things defined together help you actually map out, or they actually are what is defining your infrastructure. So that perimeter is different, but it's definitely more reliable if you could pull it together. The other thing, so one of the other things that makes the cloud so much more secure is the idea of, we could just kind of talked about the idea of putting firewalls in front of things is a little trickier in the cloud, right? So I think the firewall vendors really struggle with, because in the old world they were sell firewalls all over the place. Now we're in these workloads. It's much harder to sell a firewall in front of each workload, and then configure it to route through that firewall and all that. But AWS actually provides a lot of the idea of microsegmentation. Microsegmentation gives us so much better security. By making microsegmentation so much easier, it really raises the bar on security. I can really create workloads that are very blocked off from everything else in a snap of a finger, right? Versus in the past, if I really wanted to create a microsegmented network, I'd go buy physical devices, and I'd buy a firewall, and I'd go configure the firewall, and this would take weeks to do, right? So your microsegmentation was a hard thing to do. In today's world with AWS, it's 3 or 4 API calls, and you have a microsegmented workload that is blocked off. You could just simply turn it off, right? I mean, you can turn off, remove the internet gateway, move any VPN gateways, and that nothing can get to it, right? So it just makes it very easy to microsegment your stuff, which really makes it makes it much more secure. And don't get me wrong, we're going to need firewalls still. We're going to need firewalls in appropriate places. We're going to need web application firewalls. We're going to need all these type of things. But we're just probably going to need them in different places. We're going to have to rethink how we put them in there. We're going to have to deal with that. But it's just not simply, let me put a firewall in front of every workflow, every workload out there. So one of the most important things for security in your AWS environment is understanding VPCs, right? That's one of the fundamental building blocks is what's a VPC. The VPC, I mean, and these been around. You could still have resources in the old days, and if you look back 4 or 5 years ago, before VPCs, resources just each sat out individually and were exposed to the internet. And you could do things like not assign them IP addresses, create security groups on them that blocked it, but they were kind of individual islands upon to themselves. VPCs create that subnet, create that block that you can put resources in and define security around it. So by default, you have a VPC. Even if you don't know what a VPC is, there's one, all your resources are sitting in that VPC in a region, even if it's the default region. Now they consist of, and I'm going to go through this a little bit because actually if you want to understand networking and AWS security, understanding the idea of VPCs will get you 80% of what you need to know. So I really push you to go really spend a little bit of time reading up on VPCs and trying to understand what are all these things around there. So VPCs have internet or VPN gateways. This is just a device that connects it either to your own VPN or the world. Within the VPC, it has subnets, and these are just, again, logical groupings of stuff. It has routing tables that define how to move the traffic around. It has access control lists that are kind of like your firewall. I mean, they're very, I don't want to say not sophisticated, but they're very basic firewalls. You have your security groups, which are kind of like IP tables on each box. So you have security groups that are basically firewalls on the individual hosts. And then you have the resources that sit inside them. And there's 5 kind of resources. There's probably more than that today. It's hard to keep up, you guys know, with all the new things coming out. I know at least Amazon Workspaces can be in there, but not all resources go into VPCs, but the major ones do. If you understand this is what actually a VPC looks like. You can kind of see the outside. That's the AWS world. Within that is a region, or is a VPC. There's subnets within that. The routing table moves the stuff around, and how does things get to the outside world? So if you understand that, and then you understand 80% of what you need to know about how to architect things in AWS, how to do security architecture, how to do that kind of thing. So those routers, those VPN, virtual private gateways, go understand those, and that will get you a long ways. So network security in a VPC. So how do you do? There's 2 types of security. There's 2 levels of security you can do. Network access control lists, and by security I mean network. How you can block packets or allow packets. There's 2 different ways: through network access control lists and through security group. Network access control lists, they are set on the subnet or the VPC level, so they're kind of the wide-reaching. They'll basically control what comes in and out of a VPC. Security groups are basically you define a set of rules and then you assign it to each of the servers, each of the instances within a subnet or VPC. So they both accomplish the same thing, just in slightly different ways. And understanding the differences is important because the subtleties can come back and bite you if you don't understand these. The vast majority of people do not use network access control lists. So most people are using security groups at the instance level. So network access control lists are stateless. That means if it doesn't remember connections, a connection that comes in, it doesn't remember when it goes back out, right? So if you want to set up a NACL to allow traffic in on port 80, that traffic, when it returns back out, it doesn't go back out over port 80. It goes back out over some high port above about 500. And don't worry about the details, but it goes back out on a high port. So if you want to allow traffic over port 80 in or 443 in, then you basically have to allow, for that to work, you have to allow all high port traffic back out. So you basically have to create a rule in your network access control list that says everything above port 500, I'm just going to let out. Right, so you can see how this is problematic, right? It just because of the way that the IP protocol or the TCP protocol works, it makes it very difficult to do that very intelligently. So, but the advantage of network access control list is that you can set it one thing and it can apply to 1,000 servers, or it can apply to everything within that VPC or subnet. So, that's much more powerful, because the problem with the security group is that you can go ahead and secure everything perfectly. You have 100 instances in there, and then somebody spins up one new box in there and does not set the security group properly, then you've created that hole in the network. That one box has become the hole, because you're not locking things down at the perimeter level, you're locking them down at the host level. So the right combination of both of these is the best way to do it, is figure out, how do I do, typically if you do see somebody using NACLs, is to do deny. So for instance, you might actually see that they say, I only want, in this workload, I want nothing to come in other than port 443. And then I do have to allow the outbound, so that's, you have to live with that, but at least you've blocked anyone from possibly connecting. If somebody spins up an instance that has a security group that's open on the RDP port, and you know that that's something you definitely don't want in your workload, then you can block that at the network access control list. So I know that's a lot, but security groups, they are stateful, right? So it's much actually easier to find those, because if you define port 443, allow port 443 inbound on an instance through a security group, then you don't have to worry about the outbound, right? So it makes it much easier to actually define rules that mean something at a security group level. And you could read up more on these. Again, these are critical things that you have to understand if you're going to be security savvy in AWS, is understand these two, what's different, what are the subtle rules around them. You also have to understand, well, how do who's getting IPs, and what does this mean to my security as I set it up? So, and when you start up a resource, and the EC2 instance is the big one, when I run it inside of a VPC, it gets an instance ID, it gets a friendly name, and it also typically gets a private IP address, right? So the private IP address is typically something like a 192.168 or a 10.0. These are things that are not routable across the internet. So if you define something and the only thing it has is that IP address, it can't actually reach anything, and nobody can reach it from the outside world. So it's fairly secure. Now, what it means is anyone else on the 10.0 network or the 192.168 network can talk to it as well. So you still have threat vectors, which are somebody taking over another server and then leapfrogging that to that server that doesn't have a public IP. So don't think just because it doesn't have a public IP that it can't be attacked in any way. You still have to think through all those different factors. But by default, most of your instances only have private IPs. They also, if you indicate, and I don't know how to set it, but you can also tell it to give it a public IP. And if you give it a public IP, then you're going to see an address like a 52 dot something, or one of the well-known AWS ranges, their public ranges. So that is more of an ephemeral IP address that if you reboot the box or you spin it down and spin it back up, it will be a different IP address. So just be aware of those are public IP addresses that are not really going to be associated with your organization, but they can be vulnerable to, for instance, script kiddies who are just randomly going out there and trying to attack everything that starts with a 5.2. Right, and that's more than likely what usually happens is script kiddies is just have scripts that try to ping every IP out there that starts with 52 or starts with anything, and if they find something that's alive, then they start actually trying to do attacks on it and push it for more. So if you do have one of those public IPs, it can be connected to, even if you think, well, I haven't defined it or I haven't put it out there in the wild, it is connectable to. And then you have elastic IPs, these are the ones you define that stick around forever, and those are actually probably the most vulnerable because they're long-lived, and that would be something more likely that somebody with an agenda would go after that. So how do I run vulnerability assessment in the cloud environment? So again, terms of service from AWS do not allow you to just take your tools and point them at an instance and start running your VA tests, because VA tests can be damaging, right? And so if they do something damaging to a box, it might hurt other tenants that are sharing the hardware with you. So it's just against terms of service for you to do these things without notifying AWS filling out a form and doing all of that and defining where's this going to come from, when am I going to do it, who's the contact information. And that's typically very hard to do, particularly if you're trying to run across wide or large environments. Like, filling out a form for 700 instances is not a simple task to do. So you really have to think about, how do I do this? Are there ways to do this, using automation? And again, if you're lifting and shifting, security doesn't get a big bump up. But if you're doing this idea of using workloads that auto-scale up and down, then what you could do is start to say, well, you know what, I have an image, and this image is what everything in my workload is based off of. Can I actually scan that image once in a test environment, look for all the vulnerabilities, discover them, fix them, patch them, whatever, and then save that as my image again? So the idea of, can I scan an image and then consider everything that's running off that image has been vulnerability assessed? That's a new way to think about it, is to use that kind of strategy rather than trying to say, I'm going to scan every server in my workload that might be going away in 4 hours. So now then the question becomes, how long between when a server is spun up and it drifts away from your original AMI? So for instance, if somebody can connect to that box and start browsing, and they can go to a vulnerable site and end up with some kind of browser-based exploit, then that immediately has drifted away from the AMI, right? So now that basically needs to be tested again. So basically, when you have AMIs, you need to come up with policies for how long before this AMI's up and running that it may drift away from what I consider a secure set of configurations. So these are the things you have to think through. There's no easy answer, and I'm not actually saying this is the answer, but you have to rethink. I'm not just going to look at an IP range and scan that and call that my VA test. I now have to think about, what are my workloads, what are my AMIs, what am I scanning there? So patching strategies. Again, patching, if you're doing a lift and shift of your on-premise environment, then when a new vulnerability comes out and you have to patch, or a new patch comes out, then you got to go to every box and patch it, right? That's no easier in the cloud. It's probably a little bit easier, but it's not fundamentally easier than what you did on-prem. Now, if you instead have re-architected your apps so that I have workers that I can re-provision, or that basically get rebuilt every day or when I need to, that becomes so much easier, because now all I have to do is patch one server, and that actually can get redeployed everywhere. So the idea of this no patch strategy, stay away from patching live systems. We want to get away from lift and shift. Focus on patching the AMIs and the templates that have become the repository for these workloads. Though that's really what you need to protect and patch. And then when a new vulnerability hits, I mean, the idea, in the old world, if you had a new vulnerability hit and you had 500 servers, you knew it was going to take a year to patch 500 servers, right? Now, today, if I can go and patch one server, and with one automation script, one Jenkins script, you can go and redeploy those 500 servers, you can have your entire infrastructure patched in hours, right? So that's where the fundamental improvement in these type of, that's where the cloud provides us much better fundamental security. So this idea of, this is what I like to, or Gartner actually named, the systematic workload reprovisioning. So the idea of being able to reprovision your workload will fix so many of the problems we have. I mean, so many of the vulnerabilities that we hit today are because of unpatched systems. Systems with patches that have been available for a year, right? I mean, that is just that's the norm, right? And it's embarrassing, but that's the truth of it, is that we're not patching systems very well because we just don't have the resources, and it's tricky, it's dangerous, all of that. So DevOps, the idea of, if you've implemented DevOps processes and you're doing workload reprovisioning, that really fixes this problem and really effectively battles this advanced persistent threat idea. So as we look at VPCs, we understand VPCs now. We understand access control lists. We understand all of these things. What are we missing, right? The idea is that there's over 80 different AWS services, and there are probably 85 tomorrow. So The IAM authentication is centralized. So authentication into AWS is very centralized. But many of the systems do have their own versions of authorization and access controls. And so even if you lock down one system, it doesn't necessarily, if you've locked that down perfectly, if you've locked down VPCs, you've locked down your EC2, it doesn't mean everything else is locked down. So you have to be aware of what are the other services that I need to lock down, because if your security team audits all of your operating systems, but you left an S3 bucket wide open, then your security is no good. So think about all the different services. Think about all the different accounts. You'll probably have hundreds of AWS accounts in your environment. How do you lock down all of them? So AWS is great because it decentralizes the responsibility, but it also, that has the two-edged sword, because now, particularly, this is what scares the heck out of the security team, is all of a sudden now, all these hundreds of development teams are in total control of their own security. Right? That can be scary when you're responsible for security. So again, this goes back to the idea of automation. If you can automate how all this stuff is done, then it's much easier for a security guy to look at hundreds of accounts, look at 80 different AWS services, and feel that he's going to at least be able to fight the battle to keep that secured and locked down. So security breaches really only require that one weak link. So I like to make an analogy of, and I'm sure with the Star Wars analogy with the Death Star scenario. And I always say, why the heck do they keep putting exhaust ports on every one of these Death Stars so that one shot can blow it up, right? And that's how security actually works. I mean, the Empire is just another company just like us that has limited resources, has too much to do, and they've built this impenetrable thing. But all you need is one small hole, and really locking down every single hole. All the attackers, the rebels have to do is find that one hole. It's so much easier to find that one hole than it is to lock down every single hole across the entire environment. So this is what the hacker hopes. So it's just that our job as security people is so much harder than a hacker's job in terms of hacking. All he's got to do is find one hole. We have to lock down every single hole possible. So so think about, you've locked down all your EC2, your VPCs. RDS, again, RDS, it's a service that just listens on the database port, so they've already locked it down, so it can't be attacked on things like your SSH port or your Telnet port or things like that. It has an option to make it publicly accessible. You should try not to do this. I mean, database is just not robust enough. They have too many security kind of exploits in them that you should only, if you're going to turn this publicly accessible option on, make sure you restrict it to specific IP addresses. Make sure you're locking down the snapshots. Again, a hacker is going to realize you've locked down your RDS database so well that nobody will ever get that. So he's not going to try to go break that. He's going to go try to find a snapshot backup that you accidentally left from 3 months ago and you didn't realize that you left it out there. And that becomes your weak link, is your snapshots, right? So think about your weak link. Always consider, what are the weak links? The attacker's not going to attack the strongest part of your security. He's going to attack the weakest part. So S3. So Amazon, again, S3 sits outside of the VPC. And actually, they do have the ability these days to put VPC endpoints so you can only expose. So S3 endpoints can only be accessible from within your VPC. So that's a good thing to do, is that will secure you a bunch of the way. But most people still use it without VPC endpoints. And what that means is it's out there for the world. If I know your bucket name, I can go to my computer right now and try to connect to that. Right? So it's publicly accessible. Now the question is, did you set the security settings properly? And again, AWS has every security option you could ever want on this. Everything from 4 levels of access controls, multiple types of encryption. It has support for HTTPS. It has server access logs, all of that. So the only thing you have to do is not go open it up to the whole world. Right? And I know that's a small thing to do, but generally people just open it up and they don't even think about it. They're like, well, I'm just going to open this up, and it's a let me give you an example. I put the HR manual out there, and I accidentally made it not just read to the world, but I made it read right to the world. Well, the first thing most people say is, well, nobody cares, they're not stealing anything from you. But it becomes an attack vector, right? It becomes an attack vector because somebody could go download that file, it's a Word document, they put a macro virus in it, upload it again, and blah, blah, blah. So, always think about being as paranoid as you can with security. Security guys are very paranoid, so, and for rightfully so, because don't think about, I don't think, what are the hackers going to do with that? Always say, I need to lock things down because I assume they're clever and will find some kind of attack vector from this. So don't ever grant full control, write ACP or write bucket permissions to everyone or authenticated users. Authenticated users is an interesting permission, right? You guys have heard of that. That basically means anyone out there who has an AWS account. So it doesn't mean authenticated users in your account. It means anyone across the entire AWS environment who's authenticated. So if I went and got a stolen credit card and a burner phone and created an account, then I could just use that to use as an authenticated user. So authenticated users is basically the same thing as everyone. Consider it the same thing as everyone. So other services, Amazon SQS. Again, it doesn't live within a region. This doesn't have endpoints, but I suspect at some point you will have VPC endpoints for services like SQSQ and some of the other ones. But today, it's really a public URL. And now the URL is actually fairly, it's not secure, but it's fairly obscure. It's very hard for hackers to entirely guess what your URL looks like, because it typically has something like I think that number is probably your account, your AWS account. So it becomes a little bit harder to guess what the name of the SQS is and what your account is. But, again, I would suggest don't use obscurity as the basis for security, right? Obscurity is not security. You got to remember, what's your biggest threat? Most likely your biggest threat is an insider threat. Right? So an insider threat, somebody who's in your organization that leaves, is disgruntled, something like that, like a Snowden type of situation. So you have to understand that, even though this looks like nobody could guess this URL, leaving it wide open is still a huge security hole. So you want to make sure, for instance, with SQS, you don't leave, so you can set not IAM policy, but SQS policies that determine who can access this, whether it's a specific user or whether it's everyone. If you ever set this to everyone, it's probably a bad idea. All kinds of, again, you could say, well, what is somebody going to do with that SQSQ? There's all kinds of ideas like SQL injection and other type of attack vectors can happen here. So don't expose these to everyone. SNS, the same thing. Again, they have their own policies outside of the standard IAM policies. So you have to make sure that none of those are set to everyone. If you go and look at it and you see everyone under both of these, it's almost always a bad idea. So go set those. Turn on AWS CloudTrail. So, again, that's very easy to do. It's really the click of a button. If you go into the console, turn it on. It's really your activity monitoring for everything that everybody does at the management control plane. So it's, everything that goes through the AWS API, everything that goes through the console will get recorded here. And so this is very important to have, the biggest problem with this used to be that you'd have to turn it on in every region, and people would only turn it on in the regions that they were using. However, that's probably the worst idea, because really the attacker is going to come in and do things that in other regions that you might not even suspect, and you want to find that unusual activity. So it used to be a little bit tricky. You'd have to go to every region and enable it. They've added a nice feature where you just turn it on in one place to go across region. So make sure if your account's a year or more older, that you go and set this new option that says turn it on for all regions automatically. Because, again, why was this a problem? Because they'd add a new region, the Canada region. When that comes online next month, or hopefully, do you have to go back and enable CloudTrail for that? Do you have to go back and enable config and some of the other things for that? You don't if you've turned on this all regions setting in CloudTrail. So definitely go do that. CloudWatch logs, another nice feature that AWS has added. I mean, what's the challenge? So if you're, for instance, trying to be PCI compliant, let's say, and that requires you to keep a record of your OS logs for X months, right? You know, and so how do you do that in an auto-scaling ephemeral environment where an auditor comes in and says, show me your logs from this server from 2 weeks ago. And you look at them and say, well, that server was spun down and those logs are gone now, right? So you have to be able to answer that question when they ask that question. So CloudWatch logs is a great answer to this. Is basically you ship off all your logs from the operating system into one central repository, CloudWatch logs, stores it there so that you can have access to it for whatever regulatory compliance issues you need to do there. You know, the biggest question is volume of data. You need to be able to figure out how much of this data do I want to push? Do I want to push it all? That grows very dramatically, so you have to be careful with that. But you do have this option for CloudWatch logs. VPC flow logs, another very, very cool feature that AWS added about, I don't know, a year and a half ago. I forgot exactly when, but it basically allows you, you know, the struggle with how do I monitor what's going on the network, you know, and before they had VPC flow logs, you actually didn't even know if somebody was trying to get into your VPC and was getting rejected, right? That was kind of the scary thing, was you had no visibility into, is somebody trying to break in? So they've added VPC flow logs, which again takes the activity that's occurring at the VPC level and actually ships it into your CloudWatch logs service. So the CloudWatch log service from the last slide. This is great because you now at least can see, you can have total visibility into who's trying to break in, who's trying to access ports or IPs that you're blocking specifically, so that you at least know about it. And sometimes there's not a lot you can do about it. If people on the internet are trying to do that, what are you going to do? But at least you know what they're doing. If you're seeing that internal IPs that are trying, or internal ports that are trying to access each other and getting rejected, then you actually have a bit more concern, and that's where the bells and whistles start to go off, and you say something's wrong here. So definitely monitor for deny connections, even if you don't do anything else. Monitor for deny connections at the very least at your VPC flow log levels. So you're going to need tools to help you do this. So the services that come with AWS are very powerful. There's a lot of capabilities there, but you may need to look at other tools, tools that understand the cloud. You know, a lot of the old tools, like I said, a lot of the firewall vendors, the IDS vendors are really struggling with how do I fit into this new world. So a lot of these generic tools are falling short. So make sure you look for people that understand or are purpose-built for the cloud. You know, go look for the security competency from AWS. AWS has really done some very smart stuff by putting out all different competencies, so when you go to use a service, you could tell that it actually is going to work in this environment. So and understand tools that need a deep understanding of AWS context. How do I do actionable intelligence? So, you know, Cloud Checker is my company. We do monitoring, reporting, and optimization across cost and security. So we have a booth here. So come tonight to the booth. We'd love to talk to you more and show you a little bit what we have. But these are the ideas: visibility, optimization, analysis, control, governance. All those are things that can help you as you spin up in the cloud. So. Questions? There are actually two mics down here and two up top, and I can't see very well because of the light, so if I see somebody have any questions, I can't tell if people have questions or not. Thank you for coming, but I'll take the questions. Remember to complete your evaluation forms as well if you liked it. If you didn't like it, don't fill them out.